Hi, my name is Manasvi, and first of all, thank you for watching this. So, in this video, I'll be talking about your newly released model, which is Neobabel. Did I pronounce it correct? A multilingual open tower for visual generation. I will not go in technical depth of this paper. You guys know it better, but here's what I have to say about it. In the Neobabel paper, the author proposes a framework for multilingual text-to-image generation, addressing the bias towards the English-centric system. Basically, a model capable of understanding and generating images in multiple languages. The image generation is around 6 languages, and yes, without translation dependency. This model has achieved state-of-art multilingual performance while being 2 to 4x smaller than the competitor model. Here are 3 key questions which are addressed in this paper. Now, what was the problem with the translation pipeline? So first is the semantic drift, which means the meaning can get lost or changed during a translation. Second is cultural pattern. Imagine being loss of cultural authenticity and specificity. It means like all culture starts looking the same way from English center perspective. Third is the computational overhead, which is we need two things, a translator and an image generator. Sometimes there are translation error, generational error is equals to output error, so this can give a low level accuracy output. Talking very short about the model architecture. So the Neobabel's architecture centered around a multilingual transformer backbone integrating with a unified multi-model embedding space. The model uses a pre-trained tokenizer from multilingual LLM, which is Gemma, for textual inputs, and specially trained Magwit P2 quantizer for image, ensuring fine-grained visuals. Then talking about quantitative analysis, it has surpassed state-of-art models on multilingual benchmarks such as MGen Eval and MDPG. It's smaller yet effective architecture. In qualitative analysis, Neobabel provides seamless semantical and visual consistent output across multiple languages. The model also supports complex generative tasks like inpainting and extrapolation using multilingual prompts. Now, here's what I think. Here's what I think about how the work can be further expanded and explored. First is to include more languages, not just limiting it to 6. But when we talk about more languages, there is a problem of data dependency bottleneck. For this, we need a very high quality of data across different languages. So we can do something like we did for our Expanse project by collecting the data from humans and then generating some of the synthetic data. And yes, one thing which I forgot to mention is we need human experts because there may be a problem of geographic biasness and limited cultural diversity. So we need both synthetic as well as human data, human generated data. One more thing, I may be wrong, but recently tried Nano Banana, which uses the multimodal diffusion approach. So if we integrate it with the Neobabel, then it may address multiple limitation and also help with the in-paint feature and keep the model and help with consistency of the image. This model solves a major pain point for not only the non-English speakers but also for a prompt engineer whose first language is not English. So the key insight is that the Neobabel proves that the multilingual capability is not a trade-off but a catalyst for improved performance. There are so many points which I wanted to highlight and talk about, but time constraint. Anyways, thanks for watching.